Okay, good morning students. This is our sixth experiment regarding estimation of acidity in an acid mixture by using strong base. Okay. So this is a conductometric observation. This is one of the electroanalytical technique. Here we will use one of the conductivity cell. Okay. This is one of the conductivity cell. As you can see, this is by comparing to the reference electrode and indicator electrode. This is for different electrode. It is a combination of one of the carbon-based steel and which indicates the resistance of the solution, which arises from the conductivity of acid mixture, which contains a conductivity and when it is dissolved in water. Why? Because of the ion species present into this solution. Okay? So here the conductivity of this acid mixture will be like resistance will be arised by this one of the base, which is a new which we will take, and this base when we are adding the acid concentration, that is H plus ion concentration, which is present into this acid mixture. The acid mixture will take 50 ml. The acid mixture is strong acid, which is a hydrochloric acid, and weak acid, which is a acetic acid. Okay, that mixture which we have taken into here, but here we will give you in the standard class 5 ml that you need to make up until this mark. From this solution onwards, you need to take 50 ml into this beaker. Okay, so when I kept this indicator electrode into this solution, which is a acid mixture solution, I have not added any NaOH. Then this is the conductometer. Okay, conductometer. So the temperature is constant, and we are going to observe here because it's conductivity. Okay, so here the conductivity, and the scale must be this is the scale, that is ms, that is the Siemens. Okay, millisiemens. Okay, that we can take in millisiemens. Okay, the unit is millisiemens that we can observe. Okay, so this is the conductometer. So when I kept directly into the acid mixture, first of all you need to take the conductivity observation. This is a 7.1 millisiemens. 7.1 millisiemens. This is the conductivity, okay, of this acid mixture. Okay, then each and every time you need to add 0.5 ml of NaOH. Each and every time you need to add 0.5 ml of NaOH. Then it will indicate the conductivity of the solution. Okay, in this digital observation, you can observe the conductivity of the solution. Okay, so I will show you by adding each and every time 0.5 ml. So this is like a micro burette, okay, that you can observe easily 0.5 ml. This is the magnetic stirrer. So sorry, I forgot to explain. This is the magnetic stirrer, which it can, which is the magnetic bit we have kept into this beaker. So while it is stirring, it will form a uniform solution with the acid and base. Okay? You can see here that the conductivity of the solution by adding 0.5 ml, it is decreased. The conductivity is decreased 5.2, 7.1 to 5.2. Then you need to tabulate into this table the procedure. The volume of NaOH, first of all 0, it is a 7.1 from the digital meter which it is shown. After 0.5, you need to write what is its conductivity. It is 5.2. Okay. So then each and every time we need to observe the conductivity. So let's I am adding another 0.5 ml. Then conductivity we need to observe. We need to take another 2 to 3 minutes until it is become constant. Until it is become constant. Okay. That's it. It is not a constant. So now it is constant. There is a 3.4. Okay. You need to calculate it. Now the conductivity is decreasing. Why? Because the resistance which is created by NaOH for hydrochloric acid, okay, it is decreasing. So still we will add another 0.5 ml. Now it is constant, now it is 2.5. Okay, now still it is decreasing. See, at one point it will increase very slowly. Okay, very little bit of the increment that we can observe. Between that point is neutralization point of hydrochloric acid by hydrochloric. Now again I have added another 0.5 ml. Now it is increasing, not that much of mass, not that much of very drastically, but very slight increment, which is 2.9. Before it is 2.5, now it is 2.9. So that is a 2.4 is the neutralization point of hydrochloric acid, okay, which we are going to observe the acid mixture, which is a strong acid. Neutralization point by NaOH is 2.4. Okay, now it is slightly increasing. Still, our acetic acid is there. That neutralization point that we need to observe. Again, I am going to add another point for them. See, now it is increased slowly. Okay, before it is 2.9. Now it is increasing slowly. Now it is constant. Okay, let's see. Yeah. Now it is constant. This is 3.4. Before it is 2.9, now it is 3.4. Okay. So again I am adding another point for them. Now it is increasing slowly, not that much of drastically, slowly. Now it is 3.9. Okay. So by comparing to previous value, now it is increased a little bit. Okay. Now it is came to 4. Okay. So now it is constant. It is now 4. Again I will add. So when at one point it will increase slowly, even little bit higher. Okay. That point is the neutralization point of acetic acid. From 4 to 5, it is increasing. Immediately, at one point it is increased. Before it is 4, now it is 5.2. That is, 4 is the neutralization point of acetic acid. Okay. So now completely acid mixture is neutralized. Okay. Acid mixture is neutralized. Our initial point is 8.1. Okay. Sorry, 7.1. 7.1. So now it is 5.2. So now completely acid mixture is neutralized. So we need to do this experiment until we will get equivalent point of 7. When it is the initial conductance of acid mixture, then what is the conductance which is reached to the conductance of complete neutralization after acid mixture? Then the concentration of OH minus ion is increased into this solution. Why? Because we are neutralizing the solution with NaOH. So the OH ion concentration is increasing. H plus ion concentration is decreasing. Okay. So in this solution, now because of the OH minus ion, the conductance is increasing slowly. Okay. So because of here, now it is this point onwards, it will increase slowly. Okay. It will be a line which is very higher by comparing to acid mixture. So now I am adding another 0.5 ml to get until 7. The conductance will reach until 7. Okay. Let's see. Now it is 6.6. Now it is reached 6.6. So the OH minus ion concentration is increasing into the solution. Now I will add another 0.5 ml. Now you can see this will become more than 7. Okay, it will become 7.8. No problem. It will become more than 7.1 ml, 1 millisiemens. More than 7.1 millisiemens. So it will reach more than that acid mixture conductance. So now we can stop this experiment. Then we need to calculate it here. Now we need to calculate it here. So you can see from this value, our final volume is 4.5 ml. Okay, at 4.5 ml only we got 7.1 ml, which is equivalent to here. They in previous, this is the previous record. They take initial conductance is 8.6, final conductance 8.7. But for us is initial conductance 7.1, final conductance is 7.9. Okay, this is the measured conductance from the instrument. But we need to do a corrected conductance. The corrected conductance means it will be very close to this value. So the formula is C dash, which is the corrected conductance, C is the measured conductance, U plus V. U is the volume of base, V is the volume of acid. Okay, in the form of what is the unit? Millisiemens. Millisiemens. So when you do the calculations, you will get your values like this. Okay, so for these values, you need to draw a graph. Okay, you need to draw a graph for x-axis, volume of NaOH and conductance, the corrected conductance of acid mixture. Okay, so first of all, it is decreased. So decreased from 7.12, it is decreased. So from it is slightly increased for acetic acid. Okay, so then it is increased drastically. Okay, so now this point you need to, after drawing this point, this is for U1. When you can draw this point for U2 minus U1. Okay, so by taking this graph values for these 2 point values, you need to do the calculation in here. Volume of NaOH required to neutralize hydrochloric acid is U1. So this point is U1 and initial point is U1. So this point, neutralization of NaOH required to neutralize acetic acid is U2 minus U1. So U2 minus U1. U2 is this point. This point is U2. Then you need to take U2 minus U1. U1 is the U1 value, which is this point. Then you will get volume of NaOH required to neutralize acetic acid. Okay. So then the normality of hydrochloric acid, then you need to find normality of NaOH. We will take 0.5 normality. Okay. 0.5 normality of NaOH, and the volume of NaOH is U1 ml, which is a U1, which is a from volume of NaOH required to neutralize hydrochloric acid. Okay. If you can calculate, why? Because it is a 50 ml, that is 50 ml that we have taken this acid mixture. Okay. Then you will get a value in normality. Then actually amount of hydrochloric acid in 1 liter, that we need to find. Normality of hydrochloric acid, which is the value that you will get into equivalent weight of hydrochloric acid. Equivalent weight of hydrochloric acid 36.5. Then you will get a value in gram per liter. Okay. So then we need to estimate acetic acid. Then in acetic acid, the volume of NaOH required, that point U2 minus U1. Already I told you, from the graph you need to get this value in ml. Okay. So you need to find again normality of acetic acid with this formula. Normality of NaOH into volume of NaOH divided by 50. 50 is the volume of acid mixture. Then you will get volume in normality. Then the amount of acetic acid by liter. Then normality of acetic acid into equivalent weight of acetic acid. Then you will get the value in gram per liter. Okay. So then your result in the given acid mixture, the amount of hydrochloric acid and acetic acid present, or the hydrochloric acid and acetic acid means acid mixture. Okay. We take in 50 ml in acid mixture. In first of all is a hydrochloric acid in gram per liter. Second one is the acetic acid in gram per liter. Okay. So this is the experiment. How we need to handle this experiment, the conductometry, and how acid mixture and base, how can we need to take, and how to set up this magnetic stirrer, and also the conducting cell. This is where how to do the experiment regarding to find the by using conductometry, we need to find estimation of acid mixture by using one of the strong base. Okay. So this is the how to do the experiment. Thank you, students.